here, and just a way to think about and talk about how to think about how autism emerges over time in infancy and what we may or may not be able to predict. Um, and so we'll go from there. And this is the year, right? As Steve mentioned, we just opened up. I think we're week 3 into our new building here at the Thompson Center. Come visit. It's really a spectacular building. I'm convinced it will be the nicest building I'll ever work in. It's really a wonderful place to be. Um, let's see here. There we go. Uh, some of the work I'll be reporting on is supported by a current R01 from NIMH. I have some other work supported by NIAAA that I can give another talk on another time, Steve, if you want, which is at the other end of childhood as we look at people as they transition out of adolescence into early adulthood. And just a disclosure, some of the work on the CRY analysis that I'll present is associated with the patent and some pending patents as well. So the overall sort of, I guess, approach here is thinking about how do people develop over time, and recognizing that autism is not identified and diagnosed until toddler preschool period, but there's a lot of stuff happening developmentally in infancy, what we can think of as the prodromal period before formal diagnosis. And it's a challenging period of time to identify early indicators that might be predictive of a categorical outcome like autism, or even dimensional sort of differences in development that might be relevant to autism as well. This is probably preaching to the choir, but we think early identification is important. We think of autism as an emergent syndrome and an outcome, and that there may be opportunities in the prodromal period to identify potential targets of interventions that can help offset delays or reduce degree of impairments, improve positive developmental outcomes for infants moving forward. Even if it doesn't prevent autism per se, we want to help kids flourish and thrive. And we want to capitalize on periods of developmental plasticity. I'm whipping through a lot of these slides as background just so we can get to some of the results, but you can think of some various ways of capturing methodological approaches to looking at autism in infancy. The sort of the major approach has been to look at infant sibling studies with children who are younger siblings of children with autism, and we know there's an 18% or more recurrence rate in younger siblings, at least full siblings. But we can also look at other enriched risk or enriched likelihood cohorts, such as premature infants, and we know that there's elevated rates of autism in prematurity, and especially at younger gestational ages, and there may be even a sort of dose-response relationship between degree of prematurity and risk for autism or likelihood. There are specific genetic disorders associated with autism, and it'll be interesting to see over the next, I think, generation of researchers as genetic screening becomes more rolled out in early infancy and in the newborn period, how we might utilize those unfolding findings to capture development in individuals who first are identified with a genetic disorder and then later autism, whereas in many cases we often see autism first and then send kids for genetic testing. And then there's a challenging approach to looking at autism in general birth cohorts. Today I'm going to review some findings from some work we've been that have been associated with premature infants, and then talk a little bit about a general birth cohort that I'm working on now, with a few other findings sprinkled in here and there. The 3 cohorts that most but not all of the findings that I'll show come from have to do with 3 longitudinal cohorts. One was called the Maternal Lifestyle Study. That enrollment ended long ago, but this was a study of almost 1,400 infants with prenatal substance exposure, plus that included both substance-exposed infants and non-exposed controls. It was not an autism study, but it was large enough to capture individuals with autism outcomes. And so we engaged in a pretty laborious process of traipsing around the country to the various study sites and confirming diagnosis of autism with ABI and ADOS outcomes at 9 years or later for 13 cases in that study. The ECHO Novi study was a study of extremely premature infants born 30 weeks gestational age or younger with developmental follow-up through preschool or a little later, actually. It started off as the Novi cohort, which is a collection of special care nursery sites around the country, and it was folded into the NIH-funded ECHO cohort studies as well. And then the R01 that we have currently underway, we're in a no-cost extension period on it, currently is called the RHINOS or earlier study, began in Rhode Island. And so we used an acronym, the Rhode Island Neurobehavioral Observation Study. We opened up a new recruitment site here in Missouri when I moved to the Thompson Center. And so we have essentially two study sites for general birth cohort recruitment with some additional recruitment through the Spark research match as well. So there's a small proportion of elevated likelihood infants in the study as well. And I'll go through some of the findings from these cohorts. Some of the measures we've been using, I'll go a little history on some of these. I'll give you at least one measure of heart rate variability findings in infants from the maternal lifestyle study. I'll tell you a little bit more about the cry analysis as a measure of infant neurobehavioral integrity and arousal, and some methods that we've developed to extract automatically extract acoustic features from infant cry recorded in the first half of the first year of life. And then we also began our RHINOS, an earlier study looking at an observational measure of neurobehavioral features in infants called was originally called the NICU Network Neurobehavioral Scales. Its name has changed and it's been revised to the ends, and that's an observational exam that has some predictive validity in looking at infant neurobehavioral outcomes. Infant cry has been around for a long time as a topic. In the 60s, 70s, there were lots of highly laborious efforts to document differences in infant cry in infants with brain damage or different neurobehavioral outcomes. And a lot of it was a very laborious hand coding of spectrographs, such as you see in the right-hand panel of this cry, and qualitative descriptions of the observed cries. And as you can imagine, computerized approaches to extracting acoustic features has sped up the process of research on infant cry. We had a couple of grants that were designed to validate and develop an automated acoustic analyzer. This was done in collaboration with my colleagues Barry Lester and Harvey Silverman at Brown University, and where we developed an automated acoustic analyzer that basically is a MATLAB-based tool that points at digital recordings of infant crying, applies state-of-the-art signal processing approaches to extracting acoustic features that include fundamental frequency, which we think of as, or we perceive as pitch, different elements in the frequency domain, as well as timing characteristics of the cry. And in the top panel, you can see just a pictorial representation of an infant cry. This is about 15 seconds of a pain-elicited cry where the baby at the beginning of the left-hand panel here was probably given a little stimulus at the bottom of his or her foot to elicit a cry. So it'll flick at the bottom of the foot. There's a pause, and then a long first utterance that has a lot of turbulence and messiness in the signal at first, and then a highly resonant set of vocalization later in the vocalization. And when it becomes highly resonant and less noisy, in a sense, you can start to see the fundamental frequency, that dark bar at the bottom, that the base frequency of the cry. And then we can extract various elements of acoustics from these recordings and automatically dump these into a comma separated value uh, uh, data analysis file that at first is very detailed, sampled every 12 or so milliseconds, and then is organized into cry utterances. So you get summary statistics for what the average and range of pitch or fundamental frequency, formants, which represents other aspects of the contours of the vocal tract, frication and voicing, which get at arousal and regulation during the cry bout itself, and other features. We also measure the ends, a measure I mentioned before of neurobehavioral observational measures, and this is a relatively brief administered exam. A trained examiner will have packages of observations that look at reflexes, response to mild stressors, visual and auditory response, ability to self-soothe and regulate, and it results in summary codes for attention, regulation, quality of movement, arousal, hypo and hypertonicity, and the like. I'll just mention really briefly in terms of, because a lot of what we're starting to think about, it has to do with regulation of state and regulation of in response to mild stressors. And we did publish one paper in 2019 at looking at autonomic regulation in two papers on infants with later autism from the maternal lifestyle study. One looked at heart rate variability or respiratory sinus arrhythmia in response to a stressor in the first year of life. This paper, which was published in Biological Psychiatry, looked at longitudinal growth in RSA across the first 5 or so years of life. And what we found is that the babies with later diagnoses of autism had a flattened, slower growth in RSA compared to the non-autistic case controls who showed a pattern of increasing RSA across the first 5 years of life, and approaching adult levels in the preschool period. And so this is just one indication that something may be going on early in development that has to do with regulation of state, regulation of stress response in infants later diagnosed with autism. But a small sample, only 12 kids in this analysis sample. Back to vocalizations, we've known for a long time, and this group knows that people with autism often produce vocalizations in non-conventional and atypical ways, and it could be in later childhood and adolescence, observed in terms of unusual vocal quality or intonation and prosody differences. And this was described by Kanner in his clinical descriptions in the 1940s, has appeared off and on in various forms of the DSM, and certainly a lot in the literature. We looked at this now a long time ago. I'm getting old now, with Peter Mundy and Kim Aller, looking at vocal quality in pre-verbal, minimally verbal preschoolers with autism, and found that the children with autism produced vocalizations with elevated rates of what we termed as atypical vocalizations, atypical vocal quality. And when thinking about how we might think about prosody, intonation, vocal quality earlier in infancy, we began to think about how cry might be different, because we can record cry down to the first hours of life. And in a sense, cry is all vocal quality. It's all prosody. There's no articulation in cry. There's no syllables or anything like that. Babies aren't anatomically capable of producing sounds like that, but we can measure the vocal quality of cry down to the earliest hours of life, and therefore this might be an analog to some of the vocal quality differences that we see later in development. At least that's one of the thoughts. The other thought is that cry is an arousal response. And so we can also think of cry as a potential marker for arousal differences associated with developmental disabilities early in life, including autism. We began to look at cry in autism first with an infant sibling sample. This was in collaboration with Jana Iverson at University of Pittsburgh. And here we looked at acoustic features of cry in her sample of elevated likelihood babies in Pittsburgh and found that the high elevated risk infants produced cries at 6 months of age that were higher in pitch and more variable in pitch as well. So that would be fundamental frequency differences. We also thought, well, if you can measure differences in cry acoustically, they may be perceived differently by adult listeners. So using the maternal lifestyle study, we identified the babies with autism in that sample. We also had recorded cry in that sample as well. And we had adults, parents of young children who were naive to whether they were listening to a later diagnosed autistic baby or a non-autistic infant, had them listen to the cries, and lo and behold, the autistic cries were rated as being more atypical, sounding more distressed. This is just one of the panels from the study we published in 2019, showing that cries that were produced at 1 month of age were being perceived differently by adults who were naive to the diagnostic outcome of those babies. So that was interesting. The theory here is that if you can hear the differences in the cry, we may be able to see them acoustically as well. So we identified 13 babies, as I said before, with autism from the maternal lifestyle study. 8 of them had cry recordings at 1 month corrected age. And these cries were elicited after the neurobehavioral exam, the ENDS. We had, this was out of 1,388 babies in the study originally. We then entered both the ENDS, neurobehavioral scale scores, and the cry scores into a logistic regression model with diagnostic categorical outcome as the response variable, controlling for socioeconomic status and other potential confounding variables, and found that both the cry and the neurobehavioral features predicted diagnostic outcome in these preliminary data. And there are several sort of interesting cry features that we focus on. So how long it took the baby to cry after the eliciting stimulus was predictive of outcome. Frication, which has to do with the messiness or the mild tension in the vocal tract that may be related to arousal, was predictive of autism outcome, as well as various aspects of energy or loudness in specific frequency bands. So not overall loudness, but specific parts of the frequency domain that are showing differences in energy related to the cry. And then we also found that the ENDS seem to have some predictive validity here as well, having to do with arousal, stress signs, excitability measures in terms of predicting this outcome. And these are really preliminary data using a fairly small number of babies. But they help us motivate some work in this area. We took these data and using some bootstrapping approaches, tried to model what the predictive accuracy might be in a larger sample. And so again, I want to emphasize these are really preliminary data. Only 8 babies with the cry available. When we enter only covariates, you get a very messy ROC using these bootstrapped data. But when we enter both the CRY and the CRY plus the neurobehavioral measures, it cleans up the signal detection approach pretty nicely, and we can see a very good area under the curve. Again, this is not something we would ever say this is data that we can create a predictive tool on, but this is preliminary data that helps motivate further study. We went further with another sample, this Echo Novi sample, which is, just to remind you, a study of 700 or so infants who were born very, very extremely preterm, below 30 weeks gestational age. We have a number of outcomes in the sample, including MCHAT outcomes at age 2. And in one analysis, this was led by Coral Schuster, who was a postdoc at Brown with us at the time. And what she did was look at the degree of medical complexity in these really elevated risk babies, as well as their neurobehavioral scale scores that were performed at or around discharge from the NICU. And what we found is that elevated screening results on the MCHAT at age 2 were predicted by both degree of medical complexity, so medical events that happened during the NICU course, as well as dysregulated neurobehavioral profiles, and both of these held up in regression models. And another postdoc in the lab at the time, Andrew Maganalt, has looked at, in addition to the N, some of the CRY measures that we did. So we did the neurobehavioral scales in that study at or around the discharge from the hospital at the end of the NICU stay for these premature infants. During the ends, the babies cry because that's what babies do, right? You're fussing with them, you're doing little reflex exams, things like that. So we extracted from audio recordings of these ends exams, the cry episodes from these exams. So we had over 14,000 cry utterances from 357 babies with Bayley scales, child behavior checklist, and autism screeners at 24 months. And what Andrew found was that entering these measures into a random forest predictive model, that you found a whole bunch of predictions. So the covariates predicted these outcome measures, but CRY, when you enter the CRY together with the covariates, in individual differences in a complex array of CRY acoustics were predicting problem scores on the CBCL, lower scores on the Bayley scales, and elevated scores on the MCHAT. So again, preliminary data that's indicating that there may be some signal that's of importance in infant cry that might be tagging some important neurobehavioral features in infants. And this is a particular, interesting sample of preemies. So what are we doing next with that? We've been engaged in this other study that has to do with building on others' work in elevated likelihood infants and other enriched cohort studies, thinking about how we might look at building predictive models in general birth cohorts. This is challenging because given the epidemiology of autism, you need to have a whole boatload of babies followed over time to find infants with a diagnostic outcome. So we partnered with a program at Brown University at the time to build a newborn cohort. The institute that we partnered with was the Hassenfeld Child Health Innovation Institute, who was building a newborn cohort at Women and Infants Hospital over Rhode Island. And the idea is we would recruit babies in the newborn nursery, follow in a low intensity model for 2 to 3 years, and then have a couple of ways of bringing infants into in-person exams at 2 to 3 years of age, depending on one, whether or not there was a strong family history of autism, and two, whether there were positive indicators that using screening tools at age 2 to indicate who might be elevated risk or likelihood of autism. And in the meantime, we used highly scalable caregiver report tools in the 1 to 12-month period, and then additional surveys at 24 months. We called this study the Rhino study in Rhode Island, and then when we opened a new enrollment site at the University of Missouri, we call that the early years study. So it's the Rhinos early years study. We have enrolled. We started this study at just the opportune time. So we piloted our measures. We trained our staff to do the neurobehavioral exam and the cry recordings in the newborn nursery at Women and Infants Hospital, and we were set to open enrollment on or around the Ides of March of 2020, which was perfect timing. So everything shut down because of COVID about a week before our planned opening of enrollment. So that really threw a major wrench in the works. We had to really re-engineer the study to, if we wanted to do anything, to be much more remote. And I'll tell you how we did that. But before I tell you how we did that, just a brief rundown of what we've done in terms of recruitment. We consented a little over 2,200 infants into the study. Because of some of the complexity of enrolling babies in the newborn nursery during COVID in particular, we had about 1,900 enter into longitudinal follow-up. 1,400 have completed year 1 survey. As of January 1st or so, a little over 1,100 have completed the 2-year survey. We're still completing some of those surveys currently, so there'll be more data coming in. And we had a data freeze in December that gives us a little over 1,000 babies with 1 and 2-year outcome data. And the number of data points available for each analysis varies a little bit in terms of completeness of data at the various data points. And there's certainly missingness at each data point. And some of that is because of dropout from the study. And we recapture babies into longitudinal assessments going forward as well. So it's a bit of a complicated sample size depending on analysis. During the COVID lockdown, we had to re-engineer the study because we had originally planned to follow our method that we had done in the Echo Novi study, where we would do the neurobehavioral exam, babies would cry, and we would record those cries, but there was no way we could really do in-person exams in the COVID period. Just the changing nature of newborn nurseries did not allow that to happen. There were rolling shutdowns of who could be in or not in the nursery. Discharges from the hospital after birth became much more rapid. And so there was a compressed time for clinical care to take place. And so just too much competition to even get into the room to do that. So we recruited in the hospital, but then enrolled people in remote tools so that they completed surveys through REDCap from home, and then also completed the cry recording from home using an ecological momentary assessment tool, an EMA tool that we worked with to allow for the recording of uncompressed audio via the EMA app. So basically, parents would be consented at or around birth. They would go home with this EMA app on their smartphone. And around 4 to 5 weeks of life for the baby, the parents would get pings on their smartphone through this EMA app to complete their first survey. And the first survey is record your baby's cry. They get some direction on how to do that. They get 3 or 4 opportunities to do that right around the 1 month of age. period of time, those cries would go up to the EMA server, and then we'd bring them down into our local servers for curation, and we then extract curate the cries so we can sort of get rid of background noise and create available cries for sampling. So we had 2,700 cries that were acquired in this way from almost 1,200 infants, and those data are ready to go. I'm not going to show you more cry data, and I'll come back maybe at a later time when we have some analysis results. But what I am going to show you are data from our survey tools, which included the survey of well-being in young children. So this is an interesting study because we go from quite a high-tech sort of signal processing tool in CRY to a survey tool that is in wide use in many primary care pediatric practices around the country, the SWIC, which can be completed pretty efficiently through REDCap surveys or in pediatric offices. It includes surveys at 3, 6, 9, 12 months and thereafter. We measured developmental milestones and what's called the baby pediatric symptom checklist, which gets at temperament and sleep and emotion and sort of state regulation in the first year of life, as well as part of the SWIC. So we use these measures at 3, 6, 9, and 12 months, and then also started to measure at 12 months some early indications of autism features using the first year inventory at 12 months, the MCHAT, and the CSBS infant child checklist at 24 months. And so I'm going to show you some of those results. I'm looking through them pretty quick. I want to call out Aaron Andres, who's a really talented postdoc fellow here at University of Missouri, who's been really leading a lot of these analyses. In one initial analysis that was published last year in Pediatric Research, we found that behavior ratings using the SWIC at 9 and 12 months were related to emerging potential autism indicators using the first year inventory at 12 months. And here we found a whole bunch of correlations, basically, and I'll show you some regression to models as well. And so that slower or lower rates of developmental milestone attainment was related to differences in social communication behaviors rated by parents on the first year inventory at 12 months. Infant adaptability and temperament, both of which get at on the SWIC ability to calm and self-regulate, were also related to social communication outcomes, as well as what the FYI terms as sensory regulatory features, which may be a little bit more related to sensory responses that have some putative relationship to later autism. And interestingly, we also have parents complete the BAPQ as a measure of subclinical features of autism in parents. And the BAPQ also correlated with the parent-reported indicators in the FYI light. These are just straightforward correlations, but we also entered these assessments into two linear regression models, controlling for sociodemographic features, but as well as looking at the incremental predictive validity of these measures. And what we find is that both the social communication and sensory regulatory measure on the FYI are being predicted by higher maternal BAPQ scores. Lower milestones on the SWIC are predicting more social communication concerns. More difficult temperament also is predicting social communication concerns, and then temperament was also predicting sensory regulatory concerns. one of the SWIC measures is not purely a sleep measure, but has a lot of sleep questions on it, including difficulty getting the baby onto a sleep routine, getting the baby to sleep, calming the baby, things like that. So we began to look at how this, whether persistent sleep problems in the first year of life were related to emerging autism indicators at 12 months of age. Natalia Camelloni is one of our research specialists at the Women and Infants site, helped lead these analyses, and this was presented last year at INSAR, and what Natalia helped us identify was that infants who had persistent sleep difficulties at 9 and 12 months of age, these gray bars in the left-hand panel here, had significantly higher social communication and sensory regulatory concerns on the FYI. So some indication, preliminary data, that early emerging sleep difficulties are being reported by parents who also are reporting differences that may be related to later autism, although we don't have autism outcomes measured in full as of yet. Another interesting preliminary set of findings that is being worked on here was presented last year at the Child Psychiatry meeting in Chicago by Jane Manson, a research specialist here at University of Missouri, looked at FYI light scores, the brief version of the FYI that we use in relation to parental BAPQ scores, or broader autism phenotype features. Here, what Jane and helped us do is to look at both mother and father BAPQs. We don't always have father BAPQ scores, but we did for a substantial number. And what we found is, first of all, that parental BAPQ scores correlate with one another. And so if mother or father had an elevated BAPQ score, their partner also was likely to have a higher score as well. We could then categorize based on standard scoring from the BAPQ, elevated scores on this measure. And what Jane helped us find is that for infants who have parents who both score high on the BAPQ, their FYI light scores are substantially higher than infants who have only one parent score high in the BAPQ, or who have neither parent scoring high in the BAPQ. And so there's some interaction going on here. One that might be related to sort of family history, a new way of looking at family history of autism, or autism features, let's say, in relation to early emerging features that may be related to autism. What we have also done is, and I think this is probably the last set of findings I'll show, is to look at autism likelihood in a couple of different ways. So we can sort babies into whether or not mothers had elevated or not elevated broader autism phenotype scores. And we can also look at babies who have elevated or not elevated scores on the FYI light at 12 months of age. This gives us the sample size in our current cohort. 655 infants in our cohort are elevated on neither of these. 53 elevated on both of these indicators, and then we have 50 and 133 are elevated on one or the other. And so the next set of slides are going to sort the findings into these four groups. Aaron Andres helped lead these analyses, and these are group differences that you can see in these panels, where we find that at ages 6, 9, and 12 months of age, infants who in the light gray have the elevated indicators based both on maternal self-reported autism features, subclinical features, and early emerging features on the FYI. Those infants had slower developmental milestone attainment across the 6 to 12 month period. The infants with neither indication of likelihood of autism had the most sort of typical looking milestone attainment. Um, and in sort of a clever way, what Aaron did was to describe this by developmental milestone reported on the SWIC. And I think the group you can focus on here are these dark solid dashed lines, which correspond to the 53 high elevated in both ways infants. And these infants are showing slower growth in producing babbling sounds, showing slower growth and even a little bit of diminishment by 12 months of age, and parents report of responding to their name. Slower growth in looking for a caregiver when they're upset, playing peekaboo, response to joint attention, perhaps, where's your bottle? This is another question from the SWIC, and imitation of sounds at 9 and 12 months. Again, these are descriptive data, not statistical results, but interesting to look at. In contrast, when you look at developmental milestones such as motor milestones and fine motor milestones, sitting on their own, picking up food to eat it on their own, pulling up to standing, no substantial differences were emerging between these really elevated likelihood babies and the other groups. Nick Canay, Steve, you know this guy, has helped us look at some of the temperament features from the SWIC in a similar way. And so here we can look at the baby pediatric symptom checklist from the SWIC at 6, 9, and 12 months of age. Again, looking at the elevated babies in the light gray. These babies at 6, 9, and 12 months are being reported by parents to have higher temperament challenges, if you will, more difficult temperament, having a harder time soothed, calming down, being more irritable. And that's in comparison to the preliminary low likelihood babies, we'll call it. And you can also look at this in a item by item way, just descriptively. And we can see that the babies who had elevated scores on these two measures, the maternal DAPQ, the infant FYI light, by 9 to 12 months appeared to be being rated as more likely to cry a lot and having a harder time calming down. And then finally, we've begun to look at 24-month outcomes. We have approaching 30 babies with documented autism outcomes. Zach, you'll be pleased to know that for some of these that are in person, but we have some remote participants that we're using the telehealth ASDPs measure, which is working very nicely. But we haven't until recently had enough formal autism outcomes to really crack into those data. So for now, we've been looking at correlations and predictive associations with MCHAT outcomes. And here we find with 511 babies that were presented at last year's INSAR that the FYI light as a whole, and in particular when entered into a regression model, the social communication scale was predicting higher MCHAT and lower CSBS communication symbolic behavior scale scores at 24 months of age. And when we look categorically, we find that infants with elevated likelihood scores on the FYI light at 12 months are significantly more likely to also have positive screen results in MCHAT at 24 months. But there's an interesting thing going on, I think, with demographic features. And so we see that there may be an interaction between minority status and FYI light scores in predicting MCHAT outcomes. And we used a method looking at that people will call effect modification. So we see that the odds ratios for the non-minorities are much stronger than for racial and ethnic minorities. We grouped, this is a weakness so far until we get a larger data set, we group ethnic minorities and racial minorities together for now until we can get a big enough sample to sort of split them apart and look a little bit more detailed at what's going on. But this just is a reminder to us that we need to really be sensitive to how parents with different backgrounds, different life experiences might be responding differently to these parent-report measures. You can see this in a different way here. These are slightly, this is a larger sample that, and this will be presented at INSAR in Prague next month. Similar sort of thing where we can categorize babies based on MCHAT status and whether or not they have a elevated likelihood status based on family history of autism. And we find that the likelihood of MCHAT outcomes varies as a function of whether or not the babies have elevated likelihood status or not, but the patterns are a little different in minorities versus non-minorities. And I know we wanted a few minutes for questions, so I'm just going to sort of skip through to the end, just thinking about some themes that we can think of. One is that we want these general birth cohort studies to complement the elevated likelihood studies, so that we can document ways to do things in scalable fashion, but also document predictive associations that may be specific to elevated likelihood, high family history circumstances versus general birth cohort or general population samples as well. We suspect that some special cohorts like extremely premature babies may have their own sets of predictive modeling that we need to consider. But in general, we want to start to think about how to identify features that can help us think about screening in the prodromal period, not necessarily diagnosis, but opportunities for beginning to intervene in ways that can help prevent degree of disability, increase positive outcomes, and promote positive outcomes, even in the context of later formal diagnoses of autism as well. I'll sort of end there and just recognize the ever-growing team over the years that has contributed to this work, and recognize the funding that we've had through Safari, NIH, various institutes, the Sears Research Fund here at University of Missouri, Hassenfeld Institute, and a foundation called the Davies Team Fund as well. And I'll end there, and if you guys have questions or comments or criticisms, I am all ears.
Thank you, Stephen, so much. You feel free, if you have a question, you can either post it in chat, or I think we have about 5 or 6 minutes if you guys want to turn off your cameras and ask Steve directly. And while you contemplate your question, I can ask my first one. I just find the cry stuff so fascinating, being fascinated as a diagnostician with intonation and intonational patterns. I'm just wondering if you could speculate on mechanism. I mean, why? Like, why is a cry different? When at that early on, there's obviously something neurobiological happening. And also just coming from all the talks on genetic phenotyping with behaviors, I'm wondering, have you guys ever looked that deeply? Are there, like the 8 that you found on the one study, for example, are there genetic findings that might create a certain phenotype that you'll see in the cry? Again, I don't know how far you've gotten into that, but I'd love to hear any thoughts you have.
So those initial babies that we looked at from the maternal lifestyle study, we did not have the genetics on them. We did have some of the, get the exact proportion, but some of the babies had prenatal cocaine or opiate exposure, some did not. That didn't really seem to associate with the cry specifically. In larger samples, though, prenatal substance exposure has correlated with infant cry. Looking at the features of cry that we're finding, especially pitch and voicing frication, and how they're, at least in our preliminary data, commingling with other neurobehavioral features. I guess my hypothesis, it's not like a firm story yet, is that it seems to be in part of a arousal story, at least in relation to the developmental outcomes we're interested in here. But the genetic question is a really important one. There are definitely going to be rare genetic conditions that are going to impact cry. I mean, the classic finding is Cri du Chat, which, and forgetting if somebody else can remember the exact genetic mutation that's associated with Cri du Chat, um, you can remind me, but that is a genetic condition that results in very severe developmental disability and intellectual disability. But its earliest indicator is in the name, cry of the cat. It's a very high, unusual pitch. And so there's certainly going to be circumstances where that's going to be true. And I think it'll be interesting as we get larger samples and be able to stratify the autism developmental disability cohorts into those with positive um, um, and unknown genetic findings, or whether that helps us be more precise in what's going on with cry and also other newborn.
Do you see any, again, there's so many ways you could take this, I would imagine, right? So are there any correlations with like intonational changes, or like later on, like when I hear, at age 4, an intonational difference, is that correlated to the cry at all? Do we know? Or
I don't think there's strong findings on that. So I don't know if that's really going to be the case. Um, I know I said, originally we thought that might be a relationship there, and I'm not sure that's going to be the case. But we'll see. There are certainly others with data who can start to look at that. But I don't know if findings that speak to that.
yeah, you see
Amy Van
Amy.
Hecke has a question, I think.
Yeah, go ahead. Yeah, answer that one.
Yeah. So hi, Amy. So the question, the findings on sleep and fussiness, crying have so much direct clinical applicability. Question is, what can be done for those babies? Are there sleep or fussiness interventions out there? Seems many parents are told just to try, survive, and bear it. Whereas whether these predict autism or not, I think parents would be glad to hear that there's something that can be done. Yeah, I think this would be a great opportunity to think about, if we're identifying features that may have predictive validity, that's interesting. But then what do you do? The nice part about something like sleep, it's a discrete problem that can be supported, right? And so I think, I'm not going to pass myself off as a sleep expert, but I do know some, and I think this is this could be a great opportunity to um, marry up this kind of work with um, infancy experts in other areas who do have approaches to support parents to support their babies with sleep. And I'm not going to speculate into exactly what those are, but I do think that if we think that some of the work is around, some of the differences have to do with sort of regulation of state versus other potential influence on sleep, that might help us target those interventions. So there could be some additional work that can be done looking more specifically about what's the sort of the structure of these difficulties in sleep, which we really haven't looked at. We've looked at more broadly, is sleep difficult or not? We can look at more detail at that. That might help us think about more specific interventions.
I think we're at time. Just with regard to that, we are in talks with someone who just wrote a book, Melissa, on sleep and in autism and neurodiversity. So we're gonna invite her to give a talk too. So that might be a nice, relevant question for that. But Steve, thank you so much for your time and your expertise. It's just fascinating work. I mean, it's just one of those things I just love to hear about. And I think there's like some really interesting directions you could take this. So I really hope that you keep on pushing this envelope on this stuff. So
Thanks. I hope to join a future one. I hope to see some of everybody here in Sorrow and Prague. So.
yeah. We do have Jamie Winter is going to be speaking next month she's a ESDM and DBI master trainer. So she's coming next month to give us some updates on that type of intervention. So I hope you guys can join us next month. Enjoy the warmer weather out there. And for those of you who are going to go to Prague, we'll see you there as well. So bye, everybody, and we'll see you next month. Thanks, Steve.